Hey guys, welcome to Pre-Calc lesson 4.1, solving systems algebraically. Hopefully today's lesson will be largely review, but it's crucial for linear programming, which is what we'll be doing later on in the unit. So I want to make sure we're all on the same page, therefore the review of solving systems algebraically. Example 1, I want you to solve this system algebraically using substitution. So using substitution, the first thing we would do is solve either one of these equations for one of the variables. I'll just start with this top equation here. It'll be easy to solve for x. Move the y to the other side. X equals y minus 5. Now, if I want to solve by substitution, what I need to do is I need to take this value of x, which is y minus 5, plug it into x in the other equation. So I'll just replace that with y minus 5. Then I have plus 2y equals 4. All right, combine some like terms here. That gives me 3y minus 5 equals 4, 3y equals 9, y equals 3. Now to get my x, I just have to take this value of y and plug it into that equation I already have solved for the x, and that will get me that value. 3 minus 5, so x equals negative 2. You can leave it like that, but I'd also like you to remember that both of these equations are linear, so each one represents a line. Where the lines cross would be the point negative 2, 3. So you can either leave it like this or express it as an ordered pair. Verify graphically. All right, so to do this graphically, what we would need to do is solve each one of these equations for y. All right, and then we'll assume we're going to enter it into the calculator. So the top equation, if I solve it for y very quickly, I'll call this y1. It's x plus 5. And the second equation I'll call y2. If I get y by itself, that's going to be negative 1/2 x plus 2. All right, so enter those into the calculator. y1 looks something like this. And y2, that's not super accurate, but comes down kind of like that. And where these intersect, right there, is negative 2, 3. All right, so it just verifies our algebraic work. Okay, next one. And this is what we'll be using, to be honest with you, most of the time in linear programming. Solve algebraically using elimination. Now, at first glance, this looks very challenging because I see fractions in both equations. Well, remember how we deal with that. All right, what I want to do is I want to get rid of the fractions in each equation. So in the top equation, I'll look at my denominators, a 2 and a 4. I want to multiply every term by a number that will cancel those. Well, it happens to be the LCD, which is just 4. So I'll multiply each one by 4. And I'd like you to write it out for each term. The reason is each one cancels differently. So 2 cancels with 4, and you have a 2 left. So this top equation becomes 2x, 4 cancels with the 4, so I have 3y. And on the other side, I have 10 times 4 equals 40. Now the bottom equation, all right, let's see, the only denominator is a 2, so I'll multiply every term here by a 2. 2 cancels with that completely, so here I have 3x minus 2y equals 8. All right, so now these equations are much easier to work with. If you notice what we have here, we're going to have to multiply both equations, but it's not that bad. So here are your options. You can multiply the top equation by 3 and the bottom one by negative 2. Or since these signs are different here, multiply the top one by 2 and the bottom one by 3 if you want to cancel the y's. And that's probably what I'll end up doing. Multiply the top one by 2 and the bottom one by 3. All right, and I'll rewrite those down here. So the top equation becomes 4x plus 6y equals 80. Don't forget to multiply that number on the other side. Bottom equation becomes 9x minus 6y equals 24. Okay, so the y's cancel. 4x and 9x is 13x. 80 and 24 is 104. Obviously divide both sides by 13, and we get x equals 8. Now to get your y value, you've got a bunch of choices here. You can take this value of x, plug it in here, Don't think so. Plug it in there. Nope. I'll probably pick one of these two, and probably that top one looks easiest. So 2 times 8 plus 3y equals 40. 2 times 8 is 16, so let's subtract 16 from both sides. That gives me 3y equals 24, so therefore y equals 8. So again, you can leave it like that. That's totally fine. Or if you want to write it as an ordered pair, you could do that. You don't have to do both. Okay, moving on. Solving graphically using what we call the XY intercept method. This is a technique that you haven't learned yet. It's kind of useful, but it only works in certain situations. It's almost like a shortcut, but it will be used quite often in linear programming. Here's how it works. We need to remember the concept that if you want to find the x-intercept of something, that means you set y equal to 0. If you want to find the y-intercept of something, you set x equal to 0. So if I take this top equation here, let me rewrite it, 2x plus y equals 10, and I want the x-intercept, that means y is going to be 0. Okay, so what's left if you do that? 2x equals 10. Therefore, x equals 5. So the x-intercept of that line is 5. Let me count it out here. 1, 2, 3, 4, 5. Right there. I know that line goes through that point. Well, let's find the y-intercept. To find the y-intercept, you set x equal to 0. I'm not going to write this out every time, just for the sake of notes, I'm doing it today. So this top equation here, if you set x equal to 0, what's left? Y equals 10. Oh, okay, so let's plot that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's that point there. So if I want to sketch that line in, I know it has to connect those 2 points. Well, it's very helpful if you have a straight edge, but if you don't, you can kind of figure out what that slope is and continue that slope. I'm going to use my line tool here to get that. All right, so there is that equation. So now let's do the same thing with this one. 2x plus 2x plus 4y equals 16. So now to get the x-intercept, I'm not going to write it out again, but you set y equal to 0. So what's left in the equation when you set y equal to 0, when this goes to 0? You get 2x equals 16. So x equals 8. All right, so my x-intercept for that line is 8. 1, 2, 3, 4, 5, 6, 7, 8. Put a point there. Now let's get our y-intercept. How does that work? The y-intercept, you set x equal to 0, so this goes to 0. That's all you have left. 4y equals 16. So y equals 4. 1, 2, 3, 4. Okay, so let's connect those. And now what we have to do is find that point of intersection. Well, that point of intersection is right here. What are those coordinates? 1, 2, 3, 4, 2. So that would be the solution to that system. So again, kind of a cool technique. It's called the XY-intercept method. And the reason it works here is because I give you constants over here that are divisible by both of the coefficients of x and y. So if I put an 11 here, then this method is not nearly as fun, right? Because this would be 11 over 2. That one would be okay. For example, down here, if this was 11, it would be 11 over 2, 11 over 4. So it doesn't really work out well. When you can use this, is when these constants are divisible by both coefficients of the x and the y. All right, now let's move on to some word problems that involve systems. Example 4, you start up your own lawn mowing business. You need an initial investment of $1,500. If production costs are $3.45 per lawn and the market will bear a price of $5.95, how many lawns must you mow to break even? So apparently this question was written back in the 1960s. But anyway, so break even is a concept we need to understand in this unit. Business-wise, that means your cost equals your revenue. Money that you spend for your business equals money you get in. So let's first define a variable. X equals the number of lawns you must mow. And we're going to have two equations. One of them is your cost. One of them is your revenue. All right, well, what's your cost? An initial investment is money that you have to put into the business to start up, like price of gas, lawnmower, whatever. So that's $1,500. Production costs, $3.45 per lawn. So maybe that is, the gas it takes you to drive to the person's location, gas you have to put in the lawnmower, whatever. So your cost function is going to be this much per lawn, so 3.45x, plus your initial investment. All right, so that's 3.45x plus 1,500. It says here the market will bear a price of $5.95. Basically, that's how much you're going to charge per lawn. So that's going to be 5.95x. That's how much money you'll bring in. So if I want to know to break even, cost equals revenue, these two have to be equal. All right, so it's a very simple equation. You get 3.45x plus 1,500 equals 5.95x. All right, I'll do the algebra here very quickly. Subtract 3.45 from both sides. You get 1,500 equals 2.5x. Divide by 2.5, and x equals 600. So 600 lawns would be the number of lawns you have to mow to break even. That does not sound like a fun job to me. Anyway, moving on. All right, now this one is probably a little bit more applicable. It says Randall Pontiac offers you two different options for pay as a new salesman. Option 1 is a straight 6% commission on all sales. The second option is a flat salary of $250 per week plus 3% commission on all sales. How much would you need to sell in a given week to make the straight commission option the better choice? So again, let's define a variable. X equals the number of sales. And option 1, straight commission, 6% on all sales. So that's 0.06x. All right, the second option is a flat salary. So option 2, $250 per week. So no matter what, you get $250 plus 3% commission on all sales. How much would you need to sell in a given week to make the straight commission option the better choice? So you want this to be the better choice, or this to be more money than that. So it's actually an inequality. 0.06x is greater than 250 plus 0.03x. Okay, so we just have to solve this inequality. All right, subtract 0.03x from both sides. Divide by 0.03, and you get $8,333.33. So it says, how much would you need to sell in a given week? So there's a couple ways you can word this. You can't say this amount because that's break even. They would both be the same. So you can word it something like more than $8,333.33. That's fine. Or if you just want to go 1 cent more and say something like $8,333.34. One of those two, but you cannot say this because that's not better. That's equal. All right, so either one of those options. All right, next example here. We've done one similar to this when we dealt with matrices. This will be a little bit easier because we won't need a matrix for this. But Mr. Ward invests $18,000 into two separate bank accounts. One account earns 7.75% interest while the other earns 8.25%. If he earns $1,455 in interest the first year, how much did he invest in each account? So I need two variables. X equals the money in the 7.75% account, and Y equals the money in the 8.25% account. All right, so First equation, very simple. How much did you invest? That's x plus y. So x plus y equals 18,000. The second equation always involves the interest. So I have to multiply the interest rate times how much money is in the account. And then I have to know how much interest that equals. All right, so my second equation will be 0.075x plus 0.0825y equals 1,455. All right, just saw I made a mistake here. Hang on. That is actually going to be 0.0775x. Okay. Now, I need to solve this equation. As I mentioned earlier in this lesson, we use elimination quite often. So I notice here, I know it's going to be messy because there's decimals, but I want to multiply this top equation by this. All right, so I will multiply this equation by, let's just make it negative, negative 0.0775. So that gives me negative 0.0775x minus 0.0775y equals negative 1395. Now, obviously, the x's cancel. What I have left with the y's is 0.005y. And over here, I have 60. Divide by 0.005, and y ends up being 12,000. So I have $12,000 in this account. That's your y. To get your x, it's pretty easy. Just remember, the total is 18,000. So 18,000 minus 12,000, I don't even need to write that out. That is 6,000. All right, and our final example. This is a good one. A little physics in here. It says a boat travels downstream with the current such that a 96-mile trip is done in 4 hours. The return trip upstream takes 6 hours. Find the speed of the boat and the current. All right, well, first thing we need to discuss here is how do you calculate speed? How do you calculate time? How do you calculate distance? And there's a simple equation, D equals RT. That stands for distance equals rate times time. Now, you might learn any variation of this, R equals D over T, whatever, but this is the one I remember. I think it's the easiest one to work with. So we've got two variables here, speed of the boat and speed of the current. So I'll say x equals speed of the boat. And y equals speed of the current. Now, normally I don't write all this out, do this diagram, but for the sake of notes and because it's the first example, we need to kind of get an illustration. Here's point A, and then here's point B downstream. Okay, so we're in the stream. I know the distance from point A to point B is constant. Okay, 96-mile trip. So that's 96. I know that my current is going this way all the time. Well, in one trip, you go with the current. So if you notice here, you would add those two speeds together. And then on the return trip, you go against the current. So you'd have to subtract those two speeds. All right, so downstream, we have this situation. Distance, 96 miles, equals rate times time. Well, my time is going to be 4 hours, so I'll write that first because that's what it told me right here, 4 hours downstream. What is your rate going to be? Your rate is going to be x plus y, right? Remember this current, that's y. So since those are going in the same direction, you would add those two together in here. Upstream, it's going to be 96 equals, well, how long did it take you to go upstream? It took you 6 hours. So this will be 6 But now, let's think about it. Upstream, if you notice, I have to subtract these. Now, obviously, this is going to be greater. Otherwise, you're not making it back. So x has to go first, but it'll be x minus y. Okay? So there are our two equations that we want to solve for both x and y. So let's clean these up a little bit. I'll distribute in both cases, and I'll kind of move the x's and y's to the left. That's what we're used to. So one equation is 4x plus 4y equals 96. The other one is 6x minus 6y equals 96. Now, there's a couple different ways. We're going to use elimination here. You can multiply both equations if you want, but these numbers are kind of easy to work with, right? Think of it this way. If I take 4 and I multiply it by 1/2, that'd give me 2. If I take 6 and multiply it by 1/3, that would also give me 2. So if this were calculator inactive and you want to deal with smaller numbers, I think that's the way to go. So I will take this equation, multiply it by 1/2. I'll take this equation, multiply it by 1/3. I'll rewrite those down here. Okay, so that gives me 2x plus 2y equals half of 96 is 48. And then this gives me 2x minus 2y, and 1/3 of 96 is 32. Okay, so obviously now the y's cancel. I get 4x equals, what is that, 80? So x equals 20. So that's the speed of the current, or the boat, sorry, speed of the boat, 20 mph. Now, to get the current, you can use any equation you want. You can use one of these up here. You can use one of these here. You can use this one here. It doesn't matter. You know x is 20. So just pick an easy equation, plug in 20 for the x. I'll just pick this one here. All right, so 2 times 20 plus 2y equals 48. 2 times 20 is 40. So subtract that from both sides. 2y equals 8, y equals 4. So the speed of the current is 4 miles per hour. All right, guys, that concludes day 1 on Unit 4. Please let me know if you have any questions. Thanks for watching, and we'll see you in class soon.